stands for Cross-Industry Standard Process for Data Mining. It's a 6-phase framework used to tackle data mining projects. First, in the business understanding phase, we define the project objectives and requirements from a business perspective. Then, data understanding involves collecting and familiarizing ourselves with the data. Next, during data preparation, we clean and pre-process the data. The fourth step is modeling, when we select and apply various modeling techniques. Next, evaluation involves assessing the model against business objectives. And last, deployment is about implementing the model into operation and monitoring its performance. Let's take the retail industry as an example. During the business understanding phase, a retail company might aim to reduce customer churn. In data understanding, they collect data on various customer purchases, feedback, and engagements. In data preparation, they clean this data, handling any missing values, format issues, or any duplicates, etc. Next, modeling could involve clustering to identify different customer segments. Evaluation might assess how well these segments may predict churn within the retail business as a whole. And finally, deployment could involve targeting each segment with a different marketing strategy to see how they might or may not reduce churn. By following the CRISP-DM process, a retail company systematically approaches their problem, leading to more effective and targeted ways to address their issues. Before forecasting time series, you need to understand and decompose the data, which includes trends, seasonality, and noise. It involves checking stationarity, as most models assume time series is stationary. If it's not, we may need to transform the data, possibly by differencing. We also need to select an appropriate model, like ARIMA or A-R-I-M-A. It stands for Autoregressive Integrated Moving Average and predicts future values based on past values while adjusting for trends and cycles. Understanding the domain and the context of data is crucial for accurate forecasting. Consider the energy sector, specifically electricity demand for forecasting. Understanding seasonal trends, for example, higher demand in summer or winter, and recognizing patterns, higher use during daytime hours, for example, is crucial. They must ensure data stationarity, possibly differencing if there's a trend or seasonality. An electricity company might use ARIMA or ARIMA models to predict future demand based on past patterns. Data ethics encompasses fairness, accountability, and transparency, among other principles. Companies should ensure that data is used responsibly, protecting user privacy and ensuring consent. Organizations can uphold these principles by implementing strict data governance policies, conducting regular audits, and providing training on ethical data handling. Establishing an ethics board or committee can also help in maintaining these standards. Social media platforms are under scrutiny for data handling practices. Adhering to data ethics means transparency, informing users about how their data is used, and obtaining consent. It also involves anonymizing data to protect privacy and implementing algorithms without bias. Companies can conduct regular ethical reviews and allow external audits to ensure compliance with ethical standards. If I notice bias in our predictive models, I document specific instances and present these findings to my manager, emphasizing the potential risk to our company and to our customers. I suggest reviewing our data collection and measurement methods to identify and correct these bias sources. Implementing regular bias checks, diversifying our data sources, and involving domain experts in the process can help mitigate future biases. Transparent communication and collaboration across teams are vital for addressing these concerns effectively. Regression and classification models serve different purposes in predictive analysis. Regression is used for predicting continuous quantity like sales volume or temperature. For example, If you want to forecast next month's sales, you use a regression model. On the other hand, classification is used for predicting which category an observation belongs to. For example, whether or not an email is considered spam.